Donella Meadows, Thinking in Systems, a Primer. Dive into the captivating world of systems thinking with Donella Meadows, Thinking in Systems, a Primer. This book summary offers valuable insights into the intricacies of systems, from the elements that constitute them to the relationships that connect them. Learn about the fundamental principles that underpin various systems, such as stocks and flows, feedback, resilience, and self-organization. By mastering these concepts, readers will be better equipped to comprehend systemic behavior, identify potential pitfalls, implement effective solutions, and optimize their decision-making process in today's complex, interconnected world.
Understanding systems. All around us are different systems with elements connected by relationships and a purpose. Visible and intangible elements are held together by relationships, which determine a system's purpose. The behavior of a system is broken down into stocks and flows, which change over time. Have you ever wondered about the different systems around you? Systems are everywhere, from the human body to a football team, from companies to cities. Every system consists of elements that are connected by relationships and paired with a purpose. A tree, for example, has visible and physical elements, such as roots, branches, and leaves, held together by metabolic processes and chemical reactions. On the other hand, the intangible elements of a university, such as academic prowess, are also parts of a system that can be held together by standards for admission, examinations, and grades. The purpose of a system is not its stated goal, but its observed behavior. Therefore, if a government claims to have a goal of environmental protection but does not allocate resources to support it, then environmental protection is not their actual purpose. A system's relationships and purpose determine it, even if its elements change. For example, a football team with a new roster still has the same relationships between positions and the unified purpose of winning games. Finally, the behavior of a system is broken down into stocks and flows, which change over time. Stocks are the elements of a system that can be accounted for at any given time. On the other hand, flow is the change in stock over time as a result of inflows and outflows, such as births and deaths or purchases and sales. Understanding systems is essential to understand the world around us and can help us manage and identify problems within these systems. Understanding feedback in systems. The interplay between stocks and flows in a system results in two types of feedback, balancing and reinforcing. While balancing feedback stabilizes the actual and desired levels of stock, reinforcing feedback perpetually generates more of what already exists. A system often comprises a stock with one balancing and one reinforcing feedback. The positive birth rate serves as reinforcing feedback for human populations. However, death is the balancing feedback that kicks in as the population becomes unsustainable. In a system, understanding the interplay between stocks and flows is crucial. It is also essential to comprehend that they constantly change. Any change in stock affects the inflows and outflows of a system, resulting in feedback. This feedback helps to stabilize or destabilize a system and consists of two different forms, balancing and reinforcing. Balancing feedback stabilizes the difference between the actual and desired levels of stock by using a chain of rules or physical laws. A simple example is a thermostat that balances the temperature in a room. The room temperature represents the stock, with heat from a radiator being the inflow and heat escaping through windows as the outflow. When the temperature falls, the thermostat notes the difference between the desired temperature and the actual temperature within the room and prompts the heater to turn on. Another type of feedback is reinforcing feedback, which produces more of what already exists. An example of this type of feedback is the interest earned in a savings account. The more money saved, the more interest earned, and the more money available to save. This feedback can lead to exponential growth or destruction. A system often consists of a stock with one balancing and one reinforcing feedback. A positive birth rate serves as reinforcing feedback for a human population, as more people lead to more babies who grow up and have children of their own. However, death is the balancing feedback that kicks in as the population becomes unsustainable, resulting in disease and insufficient resources. Therefore, understanding these two feedbacks helps to comprehend how they stabilize or destabilize systems. It also helps to predict the outcomes of changes to a system and is critical in creating sustainable and resilient systems. Resilience and self-organization. Systems with resilience and self-organization are more adept at adapting to change. Do you ever wonder why some systems work so seamlessly? The answer is resilience. Resilience is a system's elasticity or its ability to recover from a transition. The feedbacks and the structure of a system determine its resilience, which works in different ways, directions, and varying time scales. However, resilience is often underrated, and people sacrifice it for goals like productivity and comfort. But when resilience is sacrificed, a system collapses, and the consequences can be catastrophic. Systems can also self-organize, learn, diversify, evolve and build on their structure. They naturally organize themselves based on a hierarchy, reducing the level of information any given part of the system has to handle, making them more adept at adapting to change. For instance, a single fertilized ovum can become a fully grown human, and everything on Earth is divided into subsystems that produce larger ones yet. Resilience and self-organization are crucial aspects of making systems more adaptable, capable of protecting themselves from invading forces, and tolerating a range of temperatures, changes in food supply, reallocating blood, and repairing bones. In a world where environmental disasters are inevitable, boosting the resilience and self-organization of our systems is essential. Misconstruing Systems. This book reframes the way we understand complex systems. It warns against our tendency to oversimplify systems and highlights 3 specific misconceptions. Our fixation on outputs causes us to overlook key behaviors that determine system performance over time. Additionally, we often anticipate linear relationships despite the real, often nonlinear dynamics of the world. Finally, we forget that systems are not isolated from one another. Our tendency towards broad or narrow thinking limits our ability to fully understand a system's interconnectedness. The book urges us to think more holistically and recognize the limits of our own cognition. The pitfalls of policy resistance. Many systems have a common framework, but policy resistance can lead to unnatural and problematic behavior. When one actor in a system pushes it in a specific direction, others will resist, resulting in a system that is stuck in an endless loop of problems. This policy resistance can be seen in drug trafficking, where traffickers and addicts want drug supplies to remain high, while law enforcement wants the opposite. The only way to correct such systems is to turn available resources towards uniting the actors in the various subsystems so that they can find a situation that works for everyone. Another problem that arises in systems is the use of a common but unsustainable resource. This eventually leads to collapse. For instance, if several shepherds use the same land and keep adding animals to their herds, the pasture will eventually degrade, leading to an inevitable collapse. To overcome these pitfalls in a system, it is necessary to educate its users on how their actions affect the resource and how to restore it by regulating its use. Transforming systems for better efficiency. The book's message is how to make systems more effective by improving system buffers, design, and delays. The optimal buffer size can help stabilize the system, but if increased too much, it can make the system inflexible. A well-designed system increases efficiency, is less prone to fluctuation, and understands its limitations. Delays must be proportional to the system's rate of change. Slowing down economic growth allows technology and prices to catch up, leading to a more efficient system. Fixing systems through information flow, self-organization, and paradigm shifts. The book emphasizes that changing physical elements can improve a system, but improving the flow of information and understanding its rules and self-organization can have a more significant impact. Installing electrical meters in hallways instead of basements, for instance, gave residents access to information about their energy consumption and reduced energy use by 1/3. However, if people who benefit from a system can exercise control over it, the system will collapse. Additionally, self-organized systems can learn on their own, but humans often fear losing control. While man-made limits may seem like a solution, they can lead to greater problems. Systems must have correct goals and paradigms, and adjusting them will change the entire system. For instance, some countries found that a centralized system of economic planning did not work for them and decentralized their system. Environmental protection paradigms have changed, leading to adaptive waste management practices in industries, people, cities, and countries. Mastering the art of systems. Learn practical steps to navigate the complexities of systems effectively. Systems cannot be controlled, and their behavior can only be understood in a general sense. However, there are simple steps that one can take to navigate the world of systems and increase their efficiency. Firstly, to observe how a system behaves, one needs to learn its history and collect data to make informed judgments. After collecting data, it is crucial to note the structural arrangements and functions of the system and double-check that models are complete and consistent. For a system to function properly, its information needs to be distributed. Therefore, the more timely, accurate, and complete the information, the better the system will run. However, it is essential to pay attention to both measurable and immeasurable factors, as humans tend to place more value on quantity over quality. Factors like justice, democracy, security, and freedom must be considered even if they cannot be quantified. Understanding how a system produces its behavior is also crucial in determining responsibility and the consequences of actions. By asking questions about external and internal influences, one can identify the factors that produce certain behaviors and assess their controllability. For instance, by understanding the reasons for a flight delay, one can avoid causing distress to a stewardess who was not responsible for the issue. Mastering the art of systems is about navigating the complexities of a system effectively by understanding its behavior, structures, and functions. With these practical steps, one can make informed decisions and take responsibility for actions within a system.
Having traversed the realms of systems thinking through the lens of Donella Meadows, Thinking in Systems, a primer, we emerge with a newfound appreciation for the intricate structures that govern our world. The book summary highlights the importance of understanding stocks, flows, feedback, resilience, and self-organization in order to navigate the complexities of modern life. By applying these principles and recognizing the dynamic nature of systems, we can become more effective in decision-making, problem-solving, and creating a sustainable future for ourselves and our planet. This transformative journey not only equips us with powerful knowledge but also enriches our perspective on the interconnected systems we interact with every day.